And I'm going to present. Damien, I might need your help to check if someone is joining because I only have one screen.
Yeah, of course. Yeah, I'll have a look.
Thank you. Cool. So, yeah, the paper we are going to discuss today is called Open-Endedness is Essential for Artificial Superhuman Intelligence. I picked this paper because I saw that this topic is becoming more popular in the community. Like this paper was presented in ICML this year, and also I saw a talk in the Machine Learning Street Talk about this open-ended AI. So I thought like it could be like one of the promising research avenues nowadays. So yeah, I think it's good for us to have the discussion of this paper. I feel like this paper is kind of philosophical though. So it's not really practical at the moment. Like it's a position paper where they argue about a particular topic. So yeah, if anyone has any opinion or like maybe also some practical side of it, like Dwayne mentioned earlier that uh, he's doing something similar with this. So yeah, please feel free to share. Yeah, okay. So what's this paper about and what actually does this paper solve? Yeah, this paper is talking about basically how we can achieve artificial superhuman intelligence or ASI with the concept of this open-endedness in AI. Uh, there are like three main contributions they are talking about in this paper. First, yeah, they mentioned that open-endedness in AI is not something new. A lot of other previous papers have talked about what is open-endedness, but they claim that their definition here in this paper is more uh, precise, and yeah, it's more like clearer and precise in terms of what open-endedness is. The second point they mention is also about the current foundation models. So they claim that the foundation models nowadays are not open-ended yet, but they have potentials to be open-ended. And that's why it's one of the ways how we can achieve ASI or the superhuman intelligence. And the third point is the safety aspects to it, because as we can imagine, like achieving superhuman intelligence definitely will uh, uh, create like safety issues as well. Um, yeah, let's see. So, okay, maybe before we start digging into this paper, I would like to make sure we are clear on the definition of artificial superhuman intelligence. It's not in this paper. Actually, I will also share a separate paper that Peter presented a while ago, like this paper called Levels of AGI. I don't remember exactly when, but it's like maybe a couple of months ago. So they here in this paper they uh, basically showed the levels of AGI, and they claim like this level 5 or the highest level, the superhuman level, is what is called as ASI. So what is ASI actually? By definition, they define the superhuman intelligence, meaning that this system, this machine, outperforms humans 100%. So they can do the task above the level of humans. Like for example, ASI can predict like the protein structure above world scientists. This is how they did with this AlphaFold. And yeah, they basically SI can do much broader, wider tasks that human cannot do. So yeah, just to keep in mind, so we are clear on what they mean by ASI. Maybe because when I started reading this paper, I was wondering like, what is ASI? What is the difference between ASI and AGI? And yeah, apparently this is like how we classify AGI. ASI is the highest level of AGI. Okay, so let's go back to the original paper. Yeah. Okay. So back to this paper. Um. They For this introduction, yeah, they claim that a lot of foundation models that we have at the moment uh is trained on various data, but at some point we will sort of like run out the high quality data to train the foundation model, and hence at some point the basically it's not open-ended, because the idea of open-ended is that the models needs to be able to always like explore new knowledge. So basically they are talking about like a lot of this argument and like other work that also like argue like why these foundation models are not open-ended, and actually combining the concept of foundation models that is trained on various tasks with open-ended concept that we're going to dig more about, actually the key to achieve ASI. Um, okay, I think it's better to go straight actually to the second section, because I do think this introduction is like sort of a summary of what they elaborate on the subsequent sections. Okay, so straight to the key of this paper. What is actually the definition of open-endedness? And why is it different to the other or the previous definition of open-endedness that were claimed by other paper? Uh, this paper claims that open-endedness is basically two things, even only if two things, which is novelty and learnable. So basically, the system is called open-ended if and only if the sequence of artifacts it produces is novel and learnable. So it has to be both. And something that we also need to pay a lot of attention at is that observer. So something can be novel and learnable for one person, but not for the other person. So this is the point that uh, also this paper is emphasizing, is that it depends, like the open-endedness of a system is depends on the perspective of the observer. Okay, let's think more about it. Like, what does it mean actually by novel and learnable? So imagine that this system creates a sequence of artifacts at particular time, and then over time it generates a new artifacts. So a system is called novel if those artifacts become increasingly unpredictable with respect to the observer's model. This is what I'm going to emphasize again, with respect to the observers, because one observer is different to another observer. And a system is called learnable if looking at like longer history makes the artifacts more predictable. Uh, let's think about examples to make it clearer for us. One example they put here is like a noisy TV program. So if you turn on your TV and then it shows like, this black and white like noise, on the screen questions that is that open-ended, is that learnable and novel. So at first, maybe when we first look at it, it seems like random noise. But if we basically create like a model that basically captures this stochasticity, like it's just like Gaussian distribution, for example, then this noisy TV system is no longer learnable, because basically we come up with a distribution that captures the stochasticity of that noise. So at first, yes, it looks new for us. Yeah, maybe it's new, but then after you find the distribution, then it's not learnable anymore. It's not. So that's why it's not seen as open-ended system. Another example is that, let's say you uh, change the TV channels. Um, every time you change the TV channels, uh, it's something new. Right? We experience novelty because one channel is different to another channel. But now it's not a learnable system because there is no uh, relation, like correspondence between the previous channels and the current channel. Like there's no pattern. So even if you pay attention to like how many channels that you have changed, you will not learn anything from the pattern, right? Because it's basically completely different. So this is also not an example of a open-ended system. Um, a lot of the other papers they claim here also mention about interestingness of a system, like other arguments like say that an open-ended system is interesting. But this paper argue that interestingness is very relative. Like it really depends on which part of the system that the observer wants to like pay attention about, like which ones are useful, and that define interestingness. So it's very ambiguous, and that's why they don't make interestingness as one like aspect of open-endedness. Hence, they stick to this novelty and learnable only. Um, yeah, cool. Let me check if I missed anything on this again. Yeah, the next section, they also compare the definition with other definitions. We touched about it before, but let's just look into it more. Um, Another description of open-endedness is that this is from another researcher like Soros and Stanley. First, it is that the individuals must meet a minimal criterion in order to reproduce, and that evolution of individuals should create novel opportunities. And then the third one, the individual themselves should make decisions about how to interact with the world, and the potential complexity of the phenotype should not be limited by its representation. Basically, they argue that uh, this definition is kind of similar, like uh, overlaps with what they claim here as definition, which is a novel and learnable. But they are they are saying that for this definition, we don't need an open-ended system to be evolutionary. But the rest is basically similar to what they claim here as novel and learnable. There's also another definition of open-endedness that they discuss here, that open-ended system is when there is something new according to the observer's perspective. They argue here that similar to interestingness, like new is like ambiguous, like new it's like really depends on the perspective, and new is basically like like novelty is more I would say like more precise than new. Yeah, like how the example of the uh, TV noise example. The next section, which I find interesting, is that about the observer. As I mentioned before, it's like something is novel and learnable. Really, that really depends on the observer's point of view. Different observers might have different opinion. A really good example for this is this picture. So let's say we have a system that designs an aircraft. A mouse, basically an animal, might think that, oh, these designs are novel, but they don't have the cognitive capability to comprehend, like to learn something about this designs. That's why it doesn't it I mean, from mouse perspective, designing an aircraft is not considered as open-ended because it's not learnable. But for a human who learns about engineering, for example, this human can see, oh, the novelty of like a new aircraft design, and they can also learn about it because they have the the capacity to learn these patterns. So it is an open-ended system for them. And for a superhuman alien might think like, oh, it's not something new. I know much more, like much better system than this. But with their capability of like intelligence, then they can still analyze a system. So it's not open-ended system for them either because it doesn't um, fall into this both of criteria. So this is why it's very important that saying something saying that something is open-ended really depends on your perspective. And here they also claim that we don't want to restrict the observers to be humans only. And there are few reasons for that. First is that they want to make sure that it's not anthropocentric. Honestly, I had to Google what does anthropocentric means. And basically it's like a system where like human is the most important creature on earth. That's my understanding. And secondly, that because the goal is to achieve this ASI, which is superhuman intelligence, it means that the observer should be more than humans because we want to exit human capabilities. Um, yeah, basically, I think they want to make sure that observer is not restrictive. I think like the third point is just the same with this first answer. Okay. They also mentioned that there is a time consideration of open-ended system. Like a system can be seen as open-ended, but not infinitely. Uh, yeah, so there can be like a finite and infinite open-ended system. An example is this agent called ADA. I'm not really familiar with this, but I saw this is quite popular. So this agent is basically able to like learn different like various kind of tasks. So at first, um if human as an observer of the system saw how this agent learns and works, it might seem as open-ended in the beginning because this agent is able to like create new like new skills to do new tasks. So there is novelty aspect as well as learnable because the human can see like, oh, how this agent like there's a pattern on how this agent become better and better. But after some point, here they say it's a month, then the agent starts to have a plateau, like it doesn't learn like new skills, like the search. space, the space when the agents can learn basically are limited. So in this case, that this is not an infinite open-ended system. This is finite and only in the horizons of like a month. Okay. And similarly, yeah, it's basically support like represented by the example I mentioned about the alien and the monkey in Monkey and Mouse, that um how we see something open-ended is also based on our cognitive ability. So let's say we read new articles in Wikipedia. We learn something about it. It's new, but at some point, like when we reach our memory limit, basically it's like it's no longer learnable. Like we will learn about the new articles, but we will forget what we read like 1 year ago. So in this case, that is not learnable because it doesn't create like more knowledge in our brain, because we will forget what we have learned before. So in this case, like it's not open-ended. Same like for a mouse, it's impossible for them to understand like why an aircraft is designed particular way. So there are a lot of aspects like why a system can be seen as open-ended that are not based on like the time, based on the observer cognitive capability, and yeah. Okay. Um, and also yeah, based also the breadth of the domain, because if we have a narrow domain, means that we only read articles on Wikipedia about a machine learning. So after we understand all of article about machine learning, then there's no more novelty. But if we don't restrict like particular domain, then like there is a more like the space is bigger, means more novelty. But remember that on the other hand, there might be a limitation of the learnability because of our brain capacity. Okay. Yeah, here they also give examples on, okay, what are the current existing systems that can be seen as open-ended from like human perspective, human as an observer. One example is AlphaGo. And why is this an open-ended system? Because when AlphaGo plays against human, they can make moves that basically like there's a low probability, like most human might not think about that move, and then AlphaGo wins because of that. And then human can learn from that AlphaGo moves, and human can basically adjust their strategy based on that to beat AlphaGo. But AlphaGo is so smart that it keeps discovering like new moves that can still beat that new human strategy. So in this situation, we can say that from the human's perspective as an observer, like AlphaGo is both novel and learnable. Like it creates new like strategy, new moves, but also humans can still learn from what AlphaGo does. But something that we need to keep in mind is that AlphaGo is an example of um, superhuman intelligence in a narrow side of it. Like, why is it narrow? Because yes, it's open-ended in this regime of playing games, but not to create new like research in like a scientific domain. So it's narrow because it's like specific in particular games domain, for example. Another example is that ADA agent that I mentioned before. Uh yeah, it's like what I mentioned before, like they can learn like new task, but at some point they reach plateau, meaning that there is no more new task to learn, and basically we will need like more like richer environment and smarter agent for that. Third example they give here is called poet, which trains a population of agents, and it has similar problems with ADA, which reaches plateau after some point. um the last example, which is the most interesting and one of the points they want to emphasize in this paper, is the foundation models. So foundation models are claimed to be not open-ended, uh, but it has potential to be open-ended. And why it's not open-ended? It's because the foundation models are trained on like a lot of data, but basically there is some like limits on those data on which foundation models are trained. So at first, foundation model might look like an open-ended system because, for example, like GPT or like any LLMs, as a human we might think like, oh, this is really good, like they are open-ended because they learn something new. Like if we like train them with like more data, they can incorporate this data in in the system. But that's because as a human we lack those knowledge, like because we don't read as much as text like LLMs did during training per se. So that's why it might seem as open-ended in the beginning, but actually at some point like there's a limitation uh on the data, like um LLMs can like learn during the pre-training time. So and what they also say here that normally when we train models and then we what to say, like there is this data distribution shift that happens. We see it as a bad way, that because like in the traditional machine learning we always think that okay, when we train a model we want to train a particular data distribution, like same even with my opinion with LLMs, like the current uh way of training is that okay, we want to get this particular distribution of this particular data, and data distribution shift is seen as something bad. But with this like regime of this open-endedness, having data distribution shift is seen as something good in a way that it promotes open-endedness, because it means that there is no like limits like on that particular distribution that the model is trained on, but we keep um expanding the distribution. Like that's the idea of like why they think like at the moment foundation models are not open-ended because the distribution is fixed, but if we make it like dynamic, it will reach open-ended at some point. um yeah okay, and one point they also want to make with this foundation model is that um let me find it. There was a sentence that we can hear, like basically the idea is that how to make foundation models open-ended is that they need to be able to like how to say, like a new adaptation of data, like okay, with this data, with this subset, sorry, with this training data, what can I, like from the perspective of the model, make new exploration. How can I find which part of the data is the more important, and how to make like new deduction of it, so instead of just like learning from the data that the model sees during training, but with open-ended foundation models, they will be able to like sort of like explore more with the given data, what can be new, what can be more important, this kind of stuff. So that's the idea of it. And how to achieve that, I feel like this is still quite very conceptual for me. So one way they mentioned is the reinforcement learning. Yeah, like we are now sort of like very familiar on how like RL agents are optimized to like get more rewards in their behavior. But one problem with reinforcement learning is that how these models can explore in like novel and learnable behaviors. So it's like, yes, the models I'll say like the models explore the solution with the motivation of this like reward, but how to make that model explores this space in a novel and learnable way, like not basically like doing the same pattern all the time, but like making like novel uh actions. um yeah, and I mentioned like basically by combining, I find it a bit difficult to understand. Like I feel like it's very conceptual for me. Like they mentioned that by combining foundation models with RL, basically the foundation models can guide the exploration towards like things that look more novel, interesting. So I feel like there are two systems. Like one is the RL who is motivated by rewards, and then a separate foundation model that basically guide RL so that um, it uh, finds new solution in a way that is new and interesting for humans. I'm not sure how it behaves in practice, so that's why I feel like it's very conceptual. But yeah, anyone, please, if you have more experience and understanding on this, just shout it. Um, Another way is this self-improvement, which they can mutually we sort of doing that at the moment. Like um I found like good examples for this, like a system that can do self-critic, self-correction, like basically something. I imagine if we have like sort of a system of LLMs that can critique the output of LLMs, it can be seen as self-improvement. That's my understanding. But yeah, to me it's also quite conceptual. Like basically, if a system can critique itself, it means that it has this capability to like uh like to create something new instead of like like stuck in this same distribution. That's how I see it. But yeah. And the third example is the task generation. So the point here is that basically to generate a task, like a system that can generate tasks with a level of difficulty that is enough to keep the new task challenging. So like remember the example of the agent AD I mentioned before, when the agent like learns new tasks, but at some point it plateaus. Like basically want to avoid that plateau because we want to always find new tasks that are challenging enough to learn by that agent. Um, and they claim here how to make that feasible. It's basically like using um, APIs to, like, as human, we do a lot of, I would say, like, I would, how to say, it's like basically the agent needs to always keep up with something new that human uh creates in this world. That's why, like, like, there are more and more tasks that the agents needs to learn, like, to keep up with, like, what human is doing. um yeah, I think this is like similar stuff. And the last point is the evolutionary algorithms. Yeah, like, basically to generate variation and evaluate the quality and diversity of attacks, and also like genetic programming, something that um can represent new mathematical knowledge. So this is like, and like, this is like four main kind of algorithms that they claim can help create this open-ended system while training foundation models. And the last part of this paper is surely to achieve the safety. I do find it's a bit paradoxal. Like, we want superhuman intelligence to be more capable than 100% humans, but to a certain extent, create, when we make sure that the safety aspects are in place, it requires humans. Like, how can humans understand the safety aspects of something that is above humans? So I feel like it's a bit paradox. I find myself a bit like confused in this. Like, um, okay, let's look into it. Like, the first point they mentioned here is about the uh how the open-ended systems take action in environment. So one example that might impose risk, for example, is this goal misgeneralization and specification gaming. So what is specification gaming? So it's something when like an agent or like a model achieve the objective but not achieving the intended outcome. So for example, if, like, let's say a student, they want to got an A in an exam, and then they cheat. So they copy their friends. Like, yes, they could get an A in an exam, but it's not achieving the intended outcome, that they learn something and they're good at it, but it's because they cheat. So that's an example of specification gaming, and it can be dangerous, right? Imagine that we I think I have this example. Let me find, like, um yeah, let's say, like, basically the human needs to be clear when designing the system, like, what are the outcomes, what are the objectives that you need to achieve. Like, you cannot achieve a particular objective without doing this. Like, we cannot have, like, a car that goes to a particular destination, but it crash it everyone on the street. Like, it achieved the objective to go somewhere, but not achieving the outcome to do it, like, safely, for example. So this is something that we need to take into account, because this open-ended system, or like this ASI, can be quite wild. And second point is that humans understanding AI creations, that human at least partially understand the significance of the new artifacts that the system produces. And any open-ended system we want to build should have the ability to bring human observers along with it. So, and it must be interpretable. So this is what I find is like paradox. Like if this system, which is ASI, is 100% better than humans, then how humans are supposed to understand them? Uh, yeah, that's why I feel like it's a bit philosophical. Um, well, they mentioned here that it's preferable to have this open-ended system that promote interpretability, explainability, or whose goal is to teach human observers, which is good. Like you have something that is much more capable than human, and then they teach human. Uh, yeah. So I feel like this one is good, but I still feel like okay, how do you assess a system that is way more like capable than you? Uh, yeah, like similarly, like the third point, humans getting aggression. Uh, so again, this is like paradox. Like it's expected that a human designer could meaningfully guide an open-ended system. So someone like a human guide an open-ended system, but in the end, this open-ended system will be much better than human. Uh, yeah, yeah, yeah. Basically, that's the idea, which in reality, I'm still not sure how. And last point is how these systems can be adapted by human society. Yeah, because yeah, definitely. Like, I feel like this is always a problem with all of this AI stuff. Like, how can you the society like accept it, and how we can measure that it benefits society, it doesn't harm, but yeah, still give us like benefits. Oh, not last point. Last point. This last point is that they also claim that let's say we have two systems, both of them are open-ended in isolation. This doesn't mean that they are still open-ended when they are interacting with each other. So I feel like this is still a very conceptual because I cannot like imagine in my head how like examples of two open-ended systems that interact. But yeah, that's the thing. So yeah, I guess that's all. Just to recap again, I feel like there are three key points that this paper are talking about. First, about the definition of open-ended, which is it has to be novel and learnable in observer's perspective. So really depends on the observer. And this is like basically one way to achieve superhuman intelligence, which is the highest level of AGI. They also claim that the current foundation models are not open-ended yet, but it has potential to be open-ended. And the last point is that again we have to keep the safety aspects in mind because this system, when deployed in like environment, it can be wild, it can achieve the outcome, so it can achieve the objective but not the intended outcome, so that can be harmful. So we need to keep that in mind. Yeah, I think that's all, guys. Anyway, so that's all from me. So any comments or thoughts, questions?
Thank you for the talk. Thank you for the paper. I've been sort of thinking about it as you were presenting it. In some ways, the point that you had about a super intelligent agent, like how do we control them? We have this problem already in open-ended systems. When a new child enters school, they might be brighter than me. They can learn far more than me, and we do already have a lot of mechanisms in place to make sure that they don't run amok. So, I mean, I think that's one way to look at it. The other thing I was thinking is the scientific method that we've got across all humanity can be seen as a open-ended system, and that we're always trying to increase the base of scientific knowledge and understanding.
Yeah.
And so do all the scientists in aggregation, are they an open-ended system? And I think a lot of it, a lot of this framework holds in that situation, and you can build parallels. And of course, the observers are like us who read papers, who are looking for new novelty. And of course, this paper is written in a way that there is one observer. But of course, we can have many observers, and the observers can change as the system in question, increases more and more in capability. Yeah, I don't know if that sparks any ideas or thoughts from anyone else, but I like their framing, and I like the paper.
Yeah, yeah, interesting. So I feel like no, my attention is drawn to what you mentioned about there's only one observer, but actually there can be many observers.
Yes.
So
Look,
there's
look at the
mhm,
peer review system in science. Where multiple observers
mhm,
are encouraging those people, those agents, learning
mhm.
to get better and better and better at in their field.
Now, yeah, I'm thinking is like because this idea of open-endedness is to achieve ASI. Does it mean that it has to be open-ended for all humans?
Yeah, good question. And do you need to get somewhere? If it's open-ended, let's say we know the first 1,000 steps of open-endedness, and like if we're on step 3, but
Mhm,
we know that the system is open-ended and will grow for forever, is that already ASI?
mhm.
Yeah.
Yeah,
Or
good.
or so do we need to know whether it plateaus or not at some point in time, or is there a set of rules that will?
Yeah. I feel like there is still no definition. Like they mentioned here, like something can be open-ended for finite time. So can we say that for a finite time something is ASI, but after a particular point in time that it's no longer ASI?
Correct.
Yeah, well, it's like philosophical discussion.
So if something is open-ended for 10,000 years, and it keeps getting better and better and better for 10,000 years, and then it plateaus, yeah.
Yeah, yeah, really good point. Anything else? Cool. If there is nothing else, I will stop sharing. Yeah, thanks again for coming to the paper talk today. Yeah. Then see you again next Thursday. Peter presenting. Next week.
Great. Thank you.
Thank you all.
Thanks.
Bye.